Adaptive learning environments. Personalizing education through data. Agenda. Learning delivery models. Adaptive learning history. Why adaptive learning? Learner model lifecycle. Getting started. Basic workflow. Knowledge tracing and mastery. Learning delivery models. A learning delivery model decides how content, pacing, and difficulty are presented to a learner over time. If every learner moves through identical material at an identical pace, some are left behind while others are held back from moving faster. Almost every education system balances a shared curriculum against the reality that learners arrive with different skills and gaps. Any program teaching a wide range of learners benefits from a way to meet each person closer to where they actually are. Teaching an entire room the exact same lesson at the exact same pace that doesn't scale to how differently people actually learn. Fixed curriculum and adaptive learning paths. A fixed curriculum delivers the same sequence of lessons every learner to every learner regardless of their current skill level. An adaptive learning environment instead continuously adjusts content, pacing, and difficulty based on how each learner is actually performing. Fixed curriculum. Same lessons for everyone. Fixed pacing. One size fits all. Adaptive learning. Khan Academy. Dreambox. ALE Chaos. Personalized per learner. Betty's room. Personalized for learner. Problems with one-size-fits-all curricula. Single point of mistake and mismatch. A lesson pitched for the average learner is too easy for some and too hard for others. Learners who fall behind early often stay behind, since the pace doesn't wait for them to catch up. Advanced learners can disengage when material moves too slowly for what they already know. No systematic way to detect exactly which specific skill or concept a learner is struggling with. Assessment often happens only at fixed checkpoints, long after a misunderstanding first appeared. Misses out on the efficiency of spending time only on what a learner hasn't yet mastered. The adaptive learning system. Learner responses are captured continuously and fed into a learner model that estimates current mastery of each skill. An algorithm selects the next piece of content, easier, harder, or a review, based on that model's current estimate. As new responses arrive, the learner model updates and the system's recommendations adjust accordingly. Well-known platforms using adaptive approaches: Khan Academy, Duolingo, ALEKS. Adaptive learning advantages: meets each learner at their actual current skill level rather than an assumed average. Surfaces specific gaps quickly instead of waiting for a scheduled test to reveal them. Keeps advanced learners challenged while giving struggling learners more practice where it's needed. Makes efficient use of learning time by minimizing review of already mastered material. Provides instructor-led and instructors with detailed, real-time visibility into where a class collectively struggles. Scales personalized instruction to far more learners than one-on-one tutoring ever could. Everything is modeled as mastery, almost. One huge benefit is that in adaptive learning environments, almost every learner action feeds into an estimate of skill mastery. Each interaction, a correct answer, a hint used, time spent updates the system's belief about what a learner knows. Progression is often gated by demonstrated mastery, not simply by time spent or lessons clicked through. This mastery based model is what lets the system make genuinely personalized recommendations instead of generic ones. Because mastery is tracked continuously, gaps are caught and addressed while they are still small. Knowledge tracing and item difficulty. Knowledge tracing estimates the probability a learner has mastered a skill. Item difficulty describes how hard a specific question is, calibrated from real learner data. A simplified knowledge tracing update. Bayesian knowledge tracing updates a mastery estimate after every learner response. Adaptive item selection. A system picks the next question based on the learner's current estimated mastery. History. Rooted in intelligent tutoring system research from the 1970s, including early systems like Scholar that adjusted to individual learners. Computer-based training in the 1980s and 1990s explored branching content, though largely without today's data-driven personalization. Bayesian knowledge tracing, introduced in the 1990s, gave researchers a formal way to estimate learner mastery from response data. The 2010s saw an explosion of adaptive platforms as cheaper computing and larger datasets made real-time personalization practical at scale. Today, adaptive techniques are increasingly built directly into mainstream educational platforms rather than treated as a separate specialty. Why adaptive learning? Personalized content and pacing respond to each learner's actual current skill level. Efficient, less time reviewing what's already mastered, more time on real gaps. Data driven, decisions are grounded in response data, not assumptions about the average learner. Scalable brings a degree of individualized instruction to far larger groups of learners. Actionable for instructors surfaces exactly where a class is struggling in near real time, continuously improving. Learner models get more accurate as more response data accumulates. The learner model. A learner model is the system's continuously adapted estimate of what a specific learner currently knows. Typically tracks mastery per skill or concept, not just an overall score. Updates after every interaction, so the model reflects a learner's most recent performance. Never treat a learner model as a fixed label. It's a constantly shifting estimate, not a permanent judgment of ability. Adaptive learning lifecycle. Capture response, assess, update mastery, model, choose next item, select, present content, deliver. A learner's response is assessed, the learner model updates its mastery estimate, the next item is selected, and new content is delivered. Getting started with adaptive learning. This leads us to the three steps that get a program off the ground. Choose a platform. Pick a platform or framework suited for your subject and learners. Define learning objectives. Break the subject into discrete, trackable skills. Calibrate content. Gather response data to calibrate item difficulty accurately. Basic workflow. Assessing, adapting, and reporting. Some call assess, adopt, and report adaptive learning's everyday loop. Every learner response is evidence the system uses to refine its mastery estimates. Content selection adjusts continuously, not just at the start or end of an unit. Instructor dashboards translate learner models into actionable, human-readable insights. Periodic recalibration keeps item difficulty estimates accurate as more data accumulates. Supports many workflows: K-12 practice, corporate training, language learning, test preparation. Works the same whether the underlying subject is math, language, or a technical skill. Any questions? Thank you.